So students, in last class we have almost completed everything whatever is required for your exam point of view. In your NEET exam we have covered everything. Now we will do some small topic and then we will do some previous year questions. So one small topic is electric field and potential due to a uniformly charged ring. So we have to find electric field and potential due to a uniformly charged ring. So we have a ring, linear charge density on this ring is lambda and the radius of the ring is capital R. We have to find the electric field at the center of the ring and then we have to find the electric field from the center of the ring on a axis, the point and the distance between the point and the center of the ring will be x. So we have to find the electric field at two places, one at the center of the ring and second one will be at a point on the axis of the ring. So at the center, to find the electric field at the center of the ring, I can divide the ring into very small elements. Due to this element, the direction of electric field will be in the downward direction, and due to this element, the direction of electric field will be in the upward direction. Similarly, due to this one it will be in this direction, and due to this one it will be in this direction. So as you can see, this point is symmetric around this charge distribution. So at the center the electric field will be 0 because electric field due to each and every small element will cancel other by the opposite element. So electric field at the center of the ring will be 0. Second thing is we have to find the electric potential at this point. To find the electric potential, again I can assume the charge on this one will be dq, charge on this one will be dq and so on. At this point the electric potential due to this dq charge will be k dq by r. Due to this one also it will be k dq by r, k dq by r and k dq by r. So total potential I can write integration of k dq by r. As you can see, k and r both are constant, they can come out. So here it will be kq divided by r. Now q is not given, lambda on this one is given, but we know lambda is equals to q divided by L, and here the ring has a length which is 2 pi r. So from here I can write q by 2 pi capital R. From here q is equals to lambda times 2 pi r. This value of q you can put here and you can find the potential due to this ring. So potential can be written as k lambda 2 pi r divided by r. From here r will cancels out and this v is equals to, so I can write this thing as 1 upon 4 pi epsilon naught. This one will be lambda into 2 pi. So from here 2 pi cancels out. From here potential will be lambda upon 2 epsilon naught. So at the center of the ring electric field is 0 and electric potential, you don't need to remember this lambda by 2 epsilon naught. You can remember potential at the center of the ring will be kq by r. So electric field at the center is 0, electric potential is kq by r, where q is the total charge on the ring. If charge is given, then the electric potential can be written directly as kq by r, and if the lambda is given, then you can use this formula to find out the electric potential at the center. Now we have a ring. This is the center, radius of the ring is r, and we want to find electric field and potential on the axis at a point. So I want to find electric field at this point, and this point is at a distance x from the center of the ring. So to find the electric field here, I need to divide this into very small point elements. So I am going to take one point element from here and I am going to take one small element from here. Charge on this one dq, charge on this one is also dq. So due to this dq charge, the direction of electric field will be away from the charge, which will be in this direction, and due to this dq, the direction of electric field will be in this direction. Now similarly, if I take one element from here, one element from here, you are going to see that electric field direction will be in different direction. But if you see, if you take two components, if this angle is, suppose this angle is theta, so this angle will also be theta, this will also be theta, and this will also be theta. So here electric field due to this magnitude it will be dE, and due to this also the magnitude will be dE. So if I take the component of this d in this direction, this component will be dE sin theta, this component will be dE sin theta, and here the component will be dE cos theta. So you will see that d sin theta components are cancelling each other out and dE cos theta components are adding up. So to find the total electric field I can write integration dE cos theta, because ultimately I have to integrate this quantity. So from here E can be written as, now dE is the very electric field due to this charge element. So due to this electric field can be written as K dQ divided by R square plus X square into cos theta. Again due to this one, electric field magnitude here will be KQ divided by this distance, and this distance is root of R square plus X square. So here electric field dE will be KQ divided by root of R square plus X square whole square, which will be R square plus X square. Now from here you can see K is constant, R radius of the ring is constant, X is the distance of the point from the ring which is also constant, and theta is also constant. So all these things are constant, I can take these things out. So here E is equals to K cos theta R square plus X square integration dQ. Now integration dQ will be total Q, so I can write this thing as Q. And from this diagram, this angle is theta, cos theta can be written as X divided by root of R square plus X square. So this electric field will become E is equals to K Q X divided by R square plus X square. This will be multiplied by the root of R square plus X square. So this total will become R square plus X square power 3 by 2. So this is the electric field due to ring on the axis. Ultimately you have to remember this formula from your NEET exam point of view. This formula is not that significant, but still you should know how to find the electric field due to a ring on the axis at the center. At the center we have seen electric field is 0 on the axis at a point which is x distance from the center. Electric field will be KQX divided by root of R square plus X square power 3 by 2. Now from this formula, as you can see, if you put here x is equals to 0, x is equals to 0 means the point is at the center. So at x is equals to 0, electric field is 0. So x is equals to 0, electric field is 0, which is at the center. Similarly, if x tends to infinity, electric field will also be 0. Because as x is increasing, here x power 1, here x power is x square 3 by 2, so which is effectively x power x cube. So x divided by x cube, so 1 upon infinity will almost be 0. So electric field at the center is also 0, electric field at infinity is also 0, which means electric field first it is increasing from 0 to some value, it will achieve a maximum value, then again it will decrease, and at infinity it will become 0. So we have to find a point where the electric field due to ring will be 0. So as you can see, electric field is variable. So if electric field is variable and you want to find the maximum, then we have to differentiate it with respect to x, then we have to make it equals to 0, then we will get the points, and then from those points we can find the maxima and minimum. So to find the maximum electric field, we are going to do dE by dx and make it equals to 0. So now if you differentiate the electric field terms, which is E is equals to KQX divided by R square plus X square power 3 by 2 if you differentiate the electric field with respect to x and solve it for 0, then you are going to get x is equals to plus minus r by root 2. So, these are the 2 points where the electric field due to ring will be maximum, and so they might ask you this thing directly, that the point where the electric field due to a ring is maximum. Electric field at the center is 0, electric field at infinity is also 0, but at a point x is equals to r by root 2 from the center, the electric field will be maximum. So, this is the electric field due to a ring at the center 0, at any distance x it will be k q x divided by r square plus x square power 3 by 2, at as the x tends to infinity it will be 0, and there will be a point which is at r by root 2 from the center, and at that distance the electric field will achieve its maximum value. From that point onwards it will keep on decreasing. Next is electric potential due to the ring on the axis. So, this is the ring again, from the center at a distance x, that is the point, this radius is r. I want to find the electric potential here. To find the electric potential here, again I can divide this into very small charge element. So, due to this very small charge element dq, electric potential here will be dV will be k dq divided by root of r square plus x square. As we have seen, electric field due to a point charge is kq divided by r. So, here kq, k is k, dq is sorry q is dq, and distance, this distance is root of r square plus x square. So, electric potential, very small electric potential due to this small element is k dq divided by root of r square plus x square. So, total electric field, as you can see, this is constant, this root of r square plus x square is also constant. So, total potential will be the integration of this, and integration of this one will be q. So, electric potential will be kq divided by root of r square plus x square. So, electric field at any distance you can find. If you want to find the electric field potential at the center, here you can keep x is equals to 0. If you put x is equals to 0, this will be root of r square, which is r. So, electric potential at the center will be kq by r. So, these are the electric field and electric potential due to a uniformly charged ring. So, with this we are done with the chapter of electrostatics. Now, we are going to do some previous year problems. So, there was a question, I am going to do a question from NEET 2017. The question says the diagrams below shows the region of equipotential. So, there are 4 diagrams given, and you have to find the work done to move a charge from A to B, and you have to compare those work done. So, equipotential surfaces are given. So, first diagram of equipotential surfaces is this. So, this potential is 10 volt, this is 20 volt, this is 30 volt, and this is 40 volt. Second kind of electric potential surfaces are given like this. So, this is 10, this is 20, this is 30, and this is 40. Similarly, here equipotential surfaces are given like this. This is 10, 20, 30, and 40. And finally, equipotential surfaces like this. (10, 20, 30, and 40). The question is asking the diagram below shows the region of equipotential, The diagram below shows regions of equipotential. So these are the equipotential surfaces. There are points A and B. Here there is a point A and there is a point B. Here also there is a point A and there is a point B. Here also there is a point A here, a point B here. Similarly, there is a point A here and point B here. Now, a positive charge is moved from A to B in each diagram. So, you are taking a positive charge, I will assume plus Q, and you are moving the plus Q charge from here to here in all the diagrams. And then you have to find the you have to find the work done and you have to compare them. As we have already know that electric work done to move a charge from is equals to change in potential energy, which can be written as Q into delta V. Yes, we have already done when we have studied electric potential energy. We have said electric potential energy or change in electric potential energy is work done by the external force. So, work done will be Q into delta V. Now, as the charge is same for in all the 4 cases, so Q will be equal, then delta V. In this case delta V is 30, in this case also delta V is 30, in this case also delta V is 30, and in this case also delta V is 30. So, in all the 4 cases the charge is same and the difference in the potential is also same. So, the total work done in all the cases will be same. So, the answer will be in all the 4 cases the work done is the same. Now, next question we are going to do from 2016. The question says that electric dipole is placed at an angle 30 degree with the electric field intensity 2 into 10 to power 5 Newton per Coulomb. So, there is a electric field, the magnitude of electric field is 2 into 10 to power 5 Newton per Coulomb. Then there is a dipole which is placed at an angle of 30 degree. So, you have a dipole and the angle between dipole and the electric field is 30 degree. It experiences a torque equals to 4 Newton meter. So, torque on the dipole is 4 Newton meter. The charge on the dipole, if the dipole length is 2 centimeter is. So, length of the dipole, which means 2d. We have already said that the distance between 2 point charges we are going to assume 2d. So, here 2d is 2 centimeter, which can be written as 2 into 10 to power minus 2 meters. So, now electric field intensity is given, torque is given, and the distance between 2 charges is given, and you have to find the magnitude of the charge. Then we have to find the charge on the dipole. As you remember, torque on a dipole can be written as tau t, the magnitude of this can be written as Pe sin theta. From here torque is 4, P you need to find, or P can be written as Q into 2d into E, which is 2 into 10 to power 5, or 2d I can write 2 into 10 to power minus 2, and E can be written as 2 into 10 to power 5, and sin theta. Theta is the angle between the dipole and the electric field. Here the angle is 30 degrees, so sin 30 will be 1 by 2. This will be 1 by 2. So, from here this will be 10 to power 3. So, this will come here. So, I can write Q is equals to 2 into 10 to power minus 3 Coulomb. So, the answer is charge is 2 micro Coulomb. 10 to power minus 3 can also be written as micro. So, next question we are going to do from 2014. So next question we are going to do from 2014. The question says, in a region the potential is represented by v x comma y comma z is equals to 6x minus 8xy minus 8y plus 6yz, where V is in volts and XYZ are in meters. The electric force experienced by a charge of 2 coulomb. So there is a charge of 2 coulomb situated at 1, 1. So there is a point 1, 1. At that point there is a charge of 2 coulomb and you have to find the electric force on that charge. So to find the electric force on the charge, the electric force on a charge can be written as Q into E. Now Q is given as 2 coulomb, but electric field is not given, electric potential is given, and we know how to find the electric field using the electric potential. So we can find the x component of the electric field using the differential. So we know the relationship between electric field and potential, which is minus of dou V by dou x I cap plus dou y j cap k cap. So if I differentiate the V with respect to x, I will get the x component of the electric field, and similarly I can find out the y and z component also. So here x component will be minus of differentiation of this whole term with respect to x will be 6 minus 8y, differentiation of this with respect to y will be minus differentiation of this one is 0, differentiation of this one is minus 8x. So minus 8x minus 8, and differentiation of this one will be 6y. Similarly, differentiation with respect to z will be, this differentiation of this one is 0, differentiation of this one is also 0, differentiation of this one is also 0, and differentiation of this one is, differentiation of this one is 6z, and differentiation of this one is 6y. So these are the differentiation with, differentiate this whole function with respect to x, differentiate the whole function with respect to y, and differentiate this whole function with respect to z. Now I can find the electric field at 1, 1. So I can write electric field as so in this one if I put both x and y as 1, 1, so this will be 6 minus 8, which will be minus 2, so this will be 2y cap. Similarly here this will be minus 8, this will be sorry, this will be minus 8, this will be minus 8, minus 8 16, and this will be 6, so this will be 10, so this will be 10 j cap minus, this will be 6, so this will be minus 6 k cap. So from here magnitude of electric field can be written as 4 plus 100 plus 36, so which is equals to, root, which can be written as root 140, and this you can write it as 2 into root 35. So this is the magnitude of the electric field, this is the charge, so total force can be written as 4 root 35 newtons. So as you can see, slightly lengthy question but very easy, you just need to pay attention while you are differentiating the function. So the answer is option D, which is 4 root 35, 4 root 35. Next we are going to do a question from 2013. The question is, two pith balls carrying equal charges are suspended from a common point by a string of 2 equal length. The equilibrium separation between them is r. Now the strings are rigidly clamped at half the height. The equilibrium separation between the balls now become. So initially you had 2 balls, they were hanged from a string of length L, and the distance between them is r. So, this is their equilibrium distance, this length is not given, this height is given, which is y. Initially equilibrium distance is this. Now, you are clamping them at half of the height. So, now the situation is something like this. This height is y by 2, and then you have to find this distance, which I am going to assume as x. So, initially the separation was r, finally because you are clamping them here, their separation is going to increase, you have to find this separation. So, as you can see, this is a standard problem, we have already done this as a standard formula. Here I can write tan theta is equals to the force between these two, I can assume this is q, this is also q. So, electrostatic force between these two will be k q square divided by r square, and the gravitational force, mass of both of them I can assume m. So, the gravitational force will be mg. Now, from this triangle you can see this is theta. So, from here I can write tan theta is equals to, so this distance will be r by 2 and this distance will be y. So, from here tan theta can be written as r by 2 and y. This is theta, this is the opposite, this is the base, tan theta is the opposite divided by base. Second thing is here, similarly I can write tan theta. Now, here theta will be different, so I am going to assume theta dash. So, tan theta dash is equals to, from here I can write k q square divided by x square divided by mg. Here again this angle will be theta dash, or to avoid the confusion I am going to assume this as alpha. So, from here the alpha will be this distance, which will be x by 2, and this distance which will be y by 2. So, I can write this thing as x divided by y. So, from here from these two equations I need to find the y. So, to find y, from here I can write kq square divided by mg as kq square divided by mg is equals to r cube divided by 2y. From here I can write kq square by mg as x cube by y. As I can see, these two are equal. So, from here I can write r cube by 2y is equals to x cube by y. From here this y will cancel out, and here from here you will get x is equals to r divided by cube root of 2. So, this is the final equilibrium distance, which is r divided by cube root of 2. Now, as you can see here, this is not that complicated of the problem, but the only thing is you have to be good at mathematics and you should be able to solve this quickly. So, this is the final answer. Next, we are going to do a question from 2011. The question says 4 electric charge plus q minus q and minus q are placed at the corner of square of side 2L. The electric potential at point A midway between the two charge plus q is. So, there is a square, side of the square is 2L. There is a positive charge P plus q, and here charge is minus q and minus q, and you have to find the potential at this point. Now, as I told you, these kind of problems generally they are easy, but they become difficult because of geometry. So, now we have to find the potential here. So, potential here I can write the potential due to this charge plus potential due to this charge plus potential due to this charge, and finally potential due to this charge. So, potential due to this charge, first charge, so I can write kq divided by L, because this distance will be L. Similarly, this distance will also be L. So potential due to this charge will be kq by L. Similarly, potential due to this one will also be kq by L. So potential due to these two will be 2 kq by L. Now I need to find the potential due to this one and this one. So as you can see, potential due to this one and this one will be the same. So I can write the total potential is equals to 2 into potential due to this one only. So to find the potential due to this one, I need to find this distance. So this distance is 2L and this distance is L. So this distance I can write root of L square plus 4L square, which is equals to root 5L. So this distance will be root 5L. So potential due to this minus charge can be written as minus kq divided by root of 5L. There are two charges, so total potential due to these two will be this. So from here I can write V is equals to 2 kq by L 1 minus 1 upon root 5. So this is the potential, and or k can be written as 1 upon 4 pi epsilon naught. So I can write this thing as 1 upon 4 pi epsilon naught 2q divided by L into 1 minus 1 upon root 5. So again you can see the question is fairly easy, but the difficult part is thinking of the geometry and finding the distances. So the answer is 1 upon 4 pi epsilon naught 2q divided by L 1 minus 1 by root 5. Next we are going to do a question from 2010. The question says the electric field at a distance 3r by 2 from the center of a charge conducting spherical shell of radius r is E. So you have a spherical shell means hollow sphere at a distance 3r by 2 from the center. So as you know, the distance of radius of the sphere is r. From the distance r by 3r by 2 will be outside the sphere, which will be, so here electric field is E. So this distance is 3 by 2 r. Electric field is E. The electric field at a distance r by 2 from the center of the sphere is. Now the distance, you have to find the electric field from the center and a distance r by 2. As you can see, the distance r by 2 will be inside the sphere, and inside a hollow sphere we have seen electric field is 0. So the answer will be electric field will be 0. So they ask this kind of statement that electric field inside the conductor is 0. They are not going to ask you directly that what is the electric field inside the conductor is 0, but they can make a question, fairly complicated questions like this, but the final answer is very easy. Next we are going to do question number question from 2007. So the question says a hollow cylinder has a charge q coulomb within it. If phi is the flux in units of voltmeter associated with curved surface B, the flux linked with the plane surface A in the unit of volt per meter will be. So there is a cylinder. This side of the cylinder is given name A, this is given as name C, and this is given, the curved surface is given name B, and total charge within the cylinder is Q, and they have said that the flux through this surface is phi. So flux through the surface B is phi, and you need to find the flux through this surface. Now as you can see, the flux, some flux will pass through here, some flux pass through surface B, and some flux will pass through surface C. So but flux through this surface and this surface will be equal, and I need to find the flux through this, flux through this one is given as phi. So I can write the flux through A plus flux through B plus flux through C is equals to total flux, which is equals to Q divided by epsilon naught. From here I can say flux through B is given as phi, so this will be phi, and flux through A and C is equal, so I can write this thing as 2 into phi A. which is equals to q divided by epsilon naught minus phi. So flux through A will be half of q divided by epsilon naught minus phi. So the answer is 1 by 2 q divided by epsilon naught minus phi. So I am going to do these problems only. I want you to solve other problems. You will find that there will be similar kind of problems where you have to find the work done, you have to find the force on the dipole, you have to find the electric field due to the dipole. Then they will give you the potential in the as a function of x, y and z. Then you have to find the electric field, or they can ask you the electric force. And in certain cases they can ask you the find the work done to move a charge from one place to another place. You know work done to move a charge is q into delta v. Then they can ask you question based on the flux. So questions are fairly simple. Only thing required is practice, because geometry will come by practice. So with that we'll end the class, and I will see you in the next chapter when I am going to take. I will see you in the next thing. So with this, electrostatics is over. I will see you in the next class. Thank you.